Hello, everyone. Thank you for joining us for the Sustainable Investment in Smart Cities webinar, where we'll discuss an IoT roadmap. Today's speakers will include Olivia Carmona, who is VP of Sales and Marketing at IoTerop. We'll also have Matt Hatton, who is the founding partner at Transforma Insights. We'll have Miguel Lira, who's the Director of Innovation and Development at Urban Control. And we'll have Valerie Grau, who is the market lead of 5G and NB-IoT at SFR, which is a branch of Altice. Today's agenda will include an overview of the smart city landscape and the strategies you'll need to succeed in the future. We'll discuss smart city technologies you should know about, and we'll also discuss interoperability. We'll discuss a roadmap for success, and we'll discuss ways to plan for updates, changes, and inevitable cyber attacks. And we'll discuss developments in the NB-IoT network, which is a pillar technology for smart cities. Before we start, there are a few housekeeping items that I want to tell you about. The first is that the webinar will be recorded, as you probably learned when you joined. And that's the reason why all participants are on mute. So if you have a question, we really encourage that and hope that you will send your question through at the end of the session during the Q&A session. Finally, the slides and the recording will be sent out after the webinar. So please look for both of those things within the next few days. Matt?
Thank you very much, Mackenzie. Delighted to be here. So I have the delight of kicking this webinar off, and I will be talking a little bit about how we define smart cities, particularly in an Internet of Things context, then some sizing, then looking at some of the technology trends that we at Transforma Insights see as being important in how smart cities develop. So at Transforma Insights, we are a research consulting firm looking at, broadly speaking, the Internet of Things, but also a lot of things around artificial intelligence, blockchain, and a whole lot of other disruptive technologies. And one of those areas where disruptive technologies might manifest themselves is in smart cities. And there are many different ways that you can define a smart city. So we ask ourselves, what is a smart city? One would be a gleaming new example, something like New Songdo City in South Korea, purpose-built from the ground up, highly sophisticated integrated solutions, and very well thought through. Equally relevant is, in fact, probably more relevant, are retrofitting of smart cities. Almost everybody lives in a brownfield smart city, the city that already exists but isn't particularly smart today. Now, there's some challenges around that. It's typically funding is more difficult to come by. It's more complex to deploy, and there's issues of governance that are clearly challenges, with different strata of government being responsible for different aspects of what happens with a city, and there's challenges of negotiating your way through that. There's also a third aspect to it, which is the smart campus, which hopefully will appear here. There we go. Which also acts a lot like a smart city. So one example we've got here is Hamburg Docks. So what you have is a large area, but actually under the control of a single entity, but runs very much like a smart city would run, benefits from a lot of the same solutions, but with a much simpler deployment environment to navigate. So the bottom line here is, when we talk about smart cities, it can cover a whole lot of different deployment environments and governance models. And there are clearly some applications that sit within smart cities as pure smart city applications, like lighting or CCTV, but others are rather more unclear. So things like autonomous driving, for instance, or supply chain, all very relevant to the city, but not necessarily maybe what we might think of as smart city applications. So many different definitions of what constitutes a smart city, but taking a narrow definition, what you're looking at here is a chart that came from a report that we published last year, looking at how demand had changed for different use cases in the Internet of Things between 2019 and 2021. Now, I don't plan on going through all of these, but towards the bottom there, you'll see smart cities as one of the segments that we focused in on. And the conclusion of the work that we've done is that actually there's a whole lot of additional demand being layered onto smart cities, both in terms of how critical the applications are and in terms of how much bandwidth is required. So for instance, there's a greater emphasis on improving the built environment within cities to prevent flight to the suburbs. There's also likely to be significant investment from government in stimulus plans to build up the economy again. And in fact, something that's cropped up just during 2022, a lot more emphasis on energy efficiency driven by the situation in the Ukraine. Now, moving on from that, again, taking the rather narrow definition of smart cities, thinking about the specific applications that we might think of as constituting smart cities. And in this context, it's a subset of the Internet of Things that we're looking at. Obviously, smart cities is more than just IoT, but here we're focusing in on the Internet of Things applications that are really the core ones for smart cities. And those core applications are things like Cctv and public space lighting, environment monitoring, and things related to transportation, public transport, or street lights, or traffic lights, or other intelligent transportation system applications, those sorts of things. Now, based on looking at these key apps, you'll notice that there's not a hockey stick growth that you might be expecting to see of some analyst predictions in the space. But really, no IoT is that kind of hockey stick growth. You've got an environment where there is a real world in which these applications have to be deployed, and the friction associated with putting these things into the real world will always act to smooth any kinds of hockey sticks. There's only a certain pace at which these things can grow. One thing that's interesting to note, we're showing the growth here from 540 million devices in 2020 to 950 million devices in 2030. China has a very big impact there. It's around 418 million going to 612 million, meaning that the rest of the world, in fact, is seeing something of a trebling of connections over the next 10 years, from about 120 million to 340 million. So the fact that China is so big already tends to have a significant impact on those numbers. But this is, as mentioned, a very narrow definition of smart cities. In fact, we can take a much wider definition to include interaction with lots of other verticals which also sit within the Internet of Things, things like smart grid or connected cars or supply chain. But in a way, the smart city is a microcosm of the Internet of Things, and a lot of the technology trends that are affecting it are technology trends that affect the whole of the IoT space. And what I'd like to do for the next part of my section is talk about some of the technology areas which have had an impact on the IoT overall, and certainly including smart cities within that. And one of those is this, what we term the Thin Iot Stack. And the idea here is, over the last decade or so, effectively what's evolved is a set of technologies which are much more appropriate, much more specifically developed to address some of the challenges associated with with the constrained environments in which the Internet of Things and smart cities deployments have to occur. And that's everything from device hardware at the bottom through networking, middleware, and the addition of some additional functionality like edge computing, which is there to cope with some of the constraints. And I'm going to talk through a few of these areas that are specifically interesting within this Thin Iot stack. So first up is the low power wide area technologies, which sat in that networking layer of the Thin Iot stack. And as an analyst, it's lovely to present market forecast slides. I'm showing another one here. What we're showing is the number of cellular based or wide area based IoT connections globally between 2020 and 2030. And you'll notice the yellow and pink bars, those are collectively the low power wide area technologies, almost 2/3 of connections in 2030, the majority of which are what we term 5G MMTC. Now, I will explain a little bit more about what I mean by that on the next slide. So these are some of the technologies that we talk about. The 5G MMTC technologies are NB-IoT and LTE-M, and then there are a couple of other technologies which are interesting in this space, LoRa and Sigfox. Now, something that unites all of these technologies is that they, as you can see from the top line, have very long battery life based on AA, AAA batteries. They would typically have 5-year plus battery life in the field. Now, that's obviously a trade-off also with the bandwidth and the other capabilities. So they are deliberately low capability in terms of bandwidth, but as a result, you get cheaper devices with a long battery life. There are other technologies that I haven't mentioned on here, but these are specifically aimed at deploying in that within that constraint of having no access to power. And as you could tell from the previous slide, we're expecting great things of these technologies, 2/3 of the wide area connections in 2030. Another topic that is very keenly followed by anyone who's involved in smart cities or the Internet of Things is edge computing. You can think of this as part of the evolution of IoT. Historically, IoT started off as being about sensing and monitoring, and then it moved to being about control, and then it moved to being about autonomy, or increasingly it's moving to being about autonomy. And as those applications become more complex, as you move through this process of sensing to control to autonomy, the smarter the edge device needs to be, particularly if you want it to be very responsive. So when it's just about monitoring, you probably don't need it to be in super real time. Whereas as you get to wanting to automate things, or certainly to control them, there's a greater requirement for very reactive and responsive capabilities. And at that point, it makes sense potentially to put the intelligence of the application onto the edge device itself rather than having it in the cloud. It's also potentially a very good way of keeping costs down, because there's typically a trade-off of processing power versus connectivity. And the question of whether Moore's law, reducing the cost of processing, is moving faster than the connectivity price erosion. But typically there's a strong argument for putting some processing closer to the edge device to reduce the requirement for connectivity costs. So intelligence moves to the edge. But there's many different kinds of edge. So there is everything from the edge device itself, the microcontrollers, through to the gateways, through to regional data centers even. Now we take an example. One example we mentioned here is the AI-enabled CCTV monitoring. So depending on what you plan on doing with the data, you may put the application logic and the intelligence at any point from the gateway through to the data center, depending on how much of the data you actually want to transport or how much you want to process on the device. If all you're doing is doing automatic number plate recognition and sending a alphanumeric string of 7 or 8 characters, then you don't need an awful lot of processing in the core. Most of it is handled at the edge device. So very interesting topic to keep watching. A couple of others to whiz through quickly. One is a very cool area around data exchanges. Now, obviously, everyone knows the value of IoT is in the data, but typically that's got 2 elements. Firstly, there's the value of the data to the owner themselves and what they'll pay to get it, and then also what other people will pay to access it. So it's valuable to people other than just the organization that develops it. And what we're seeing is the emergence of some infrastructure to allow other organizations to access data generated by different IoT devices. And this tends to manifest itself first in the smart city space, because it is there where sharing of data is generally seen as being most common and having the greatest value. But to work properly, you really need to understand what a piece of data means. And so you need a common set of semantics and ontologies to describe the data and allow somebody to identify which piece of data it is. And so this is again another interesting technology trend that we're watching. And finally, from me, I want to talk a little bit about enterprise demands. We did a survey last year, and I want to leave you with some thoughts from or considerations from the organizations who are deploying. So in the case of the public services, we asked, okay, which ways can solutions providers help you with your IoT deployment? And it tends to be in terms of helping with improving automation and integration. So having all of the elements of a solution work together, that's certainly the next phase of getting IoT to work properly, having got all of those cool elements of the Thin Iot Stack working together. Also important, making the business case work for smart cities. But at that point, I'm going to hand on to Miguel, who is going to speak about smart city technologies you should know about. Miguel, over to you.
Thank you, Matt. Good afternoon. And thank you all for joining me and my colleagues for this session. It's a real pleasure to be here and having the opportunity to present my view on technologies for smart cities and how important is the interoperability for massive IoT. So introducing myself, I'm Miguel Lira, Innovation Development Director of Urban Control, with 25 years of experience in the electronic and control industry, and with the last 15 focused on outdoor connected solutions. A bit of who we are. Quick introduction of Urban Control. So we are a private UK company running year 7 of operation, and since last October, we are now part of a bigger family. We develop IoT solutions for smart cities based on technologies and open standards that we consider the most relevant in this industry. We also have a proven track record of projects, counting with a few hundreds of thousands of devices deployed in several regions of the world. So I will also start with a definition. What is a smart city to, let's say, to us? And there are several definitions and interpretations of what a smart city is. But in general, I think we can agree on some common characteristics. It's an urban area, but not only, as many projects can be extended beyond the urban area limits. It uses some form of electronic technology to collect and gather data from a physical device. Could be an air quality sensor, a traffic counting camera, for example. It could be from an asset, a luminaire, a bridge, a highway. Could be from people, like detecting people's movement, the density of a crowd, and could be from other sources of data. That data is then sent to a network that is connected to some backend service that will process and use it to manage more efficiently the city's assets, services, and resources, reducing energy costs, carbon emissions, and light pollution, and which in turn will lead to a more sustainable and attractive city to live in. Note that with more than half of the world's population living in cities, millions and millions of smart IoT devices are expected to be deployed during this decade, raising a number of challenges that need to be addressed to overcome the proper technology selection. So there is a wide range of options when it comes to IoT technologies, but not all are suitable to overcome the challenges imposed by the requirements of a smart city. And ultimately, the choice of a less fit technology will dictate the failure of a smart city vision. So there are critical factors that must be considered when making an evaluation of the most fit IoT solution. And usually they are related with the network complexity. So what is the effort to have the network infrastructure in place? And its coverage, the availability of enough signal to connect to that network. The bandwidth, the volume and number of simultaneous connections, the data throughput, so the speed of the communication, latency, delay between the action and response, and the resilience of that network, so the resistance to disruptions. There are device constraints, cost, data privacy and security, and standardization and interoperability. So in the next slides, we will explore a bit more in detail these key factors, comparing the most commonly used IoT technologies. I'll start with coverage. Designing a good network infrastructure to provide enough coverage is a complex task, requiring a high level of expertise and capital. Network coverage will be influenced by the signal availability spread around the city and how far each IoT device may reach per hop. The topology of the network, for example, a mesh or star topology, also plays an important role on desired coverage, and it may imply a high number of network components to achieve optimal coverage. The frequency spectrum used, for example, if it's sub-gig, 2.4 giga or other, also impacts the speed, the range, and building or underground penetrations. If the IoT device is mobile, then only a few network types will suit the application, the mobile networks. Some of these networks are already in place and reduce a lot this complexity, providing widespread coverage, even at country or global scale, as the existing cellular, LTE-M, and NB-IoT technologies supported by the 4G and 5G networks. What about that bandwidth and data throughput? Bandwidth is shared across the entire network, and it affects both the volume of messages IoT devices can send and the size of the data packets they will include. A lot of IoT applications don't require much data throughput, but if your device involves processes like streaming video or transmitting real-time data, speed is vital. Data throughput is also important if you plan on delivering remote firmware updates to keep your device secure, to fix bugs, or add new features. The ability to deliver firmware updates over the air helps future-proofing your devices, but without enough data throughput, IoT manufacturers can send them to battery-powered device, or they would drain their batteries otherwise. So slower technologies as the ultra-narrowband, like Sigfox, for example, suffer from this problem, and working at speeds of hundreds of bits per second only, it struggles to keep the device constantly updated and secure. Power consumption. Power consumption of IoT devices is a combination of factors like the network topology and the role of the device plays on keeping it running. I'm thinking about, for example, the mesh topology, where every device may be requested to participate as an active element of the network itself, and that consumes energy. Data throughput, so the faster the device transmits and receives data, the less on-air time it needs, and therefore will use less energy. But even regulatory limits imposed to the radio's power will influence its power consumption. The network's power consumption also depends on your use case. For example, how often you need to transmit. If it's bidirectional, the number of real-time commands issued. And if it's battery powered. In this case, the battery has to last for the entire life cycle of the device, and that means your connectivity solution can consume too much power. Some specialized solutions like NB-IoT and LTE-M have power-saving features to extend the battery life of the IoT devices that can last for a decade on the field. Cost. All the previous mentioned factors will impact the cost of the IoT solution, as nothing comes for free. How we combine them will dictate not only the capital investment needed from the city, but, and many times more important, is the ongoing operational costs it will carry for many, many years ahead. If a network is already deployed and you simply have to connect your device to it, like the cellular network, the deployment costs won't include buying and building network infrastructure. But as with any other network technology, you'll have to evaluate the equipment you need to connect to, such as the radio modem, the SIM card, or something you'll need to acquire again for every deployment, as a gateway or a router. Deploying proprietary connectivity infrastructure adds ongoing maintenance and operation costs, which will require you also to invest in personnel. More complex networks may also increase your development costs, as your device will need to be compatible with the proprietary protocols and technologies the connectivity solution requires. And of course, you need to consider the ongoing costs of power and data consumption. With increasing deployment and adoption of narrowband cellular technologies, affordable data plans, and a more compact and efficient hardware, the LTE-M and the NB-IoT technologies are becoming much more cost attractive nowadays. Security. With billions of IoT devices projected to be connected to the cyberspace, IoT security is a critical aspect of a smart city solution. Today, and incredibly, most of the transmitted data is still pretty much unsecured, and IoT devices can be hijacked and hacked to be used as an entry door to your network, granting a hacker access to computers, servers, and other entities on the same network. Firmware updates are crucial and allow to repair breaches in IoT security, but not all network technologies will enable to deliver them because they have limited bandwidth or limited security capabilities. Security must be designed and implemented from end to end, including the device hardware, its embedded software, communication protocols, and the servers on the net. And the importance of interoperability. Interoperability is a characteristic of a product or a system to work with other similar products or systems from different manufacturers, allowing data exchange using open standards. Note that when one must adapt its solution to a proprietary system, we'll be speaking about compatibility and not about interoperability. Interoperability is a key factor for today's smart cities. Proprietary IoT solutions frequently lead to vendor lock-in, difficult and expensive integration with others, poor or none updates, and eventually its obsolescence. With increasing standardization at all levels of solution, like using UC-FHIR data models or a lightweight M2M application protocol, the talk interface, the increased security features, the wider network coverage, and the proper device management, scalable deployments and future-proof solutions are becoming a sustainable reality for smart cities. So, which IoT technology will be the best fit for a smart city? Tough question. Obviously, there isn't one single technology that will fit all the requirements, but decision should favor technologies that minimize data consumption, energy usage, overall cost, and maximize network and complexity and coverage, bandwidth and data throughput, security, and the interoperability between devices and systems. So all things considered, this combination can be mostly achieved with today's low power cellular LTE-M, NB-IoT, and Wi-Fi mesh networks using open standards for interoperability. So this concludes my presentation for today. I thank you very much for your time, and I will pass the word to Olivier now.
Thank you, Miguel. Thank you for your presentation. So I'm Olivier Carmona. It's my pleasure to host you and all our partners today on this webinar. This webinar is part of a long series of webinars that we have been running. And we are running those webinars to help our clients share their experiences building sustainable businesses. And today I will focus on how our customers are building a path to a sustainable city. So I'll focus on what Miguel just described, which is the portion of the sustainability and the firmware updates, and how that helps coping with firmware updates and with cyber attacks. So first, maybe a first word about who we are. So we are a company that is private, having sales representative in France, Australia, Taiwan, Singapore, and Netherlands. We are automating the life cycle of our customer constrained devices on constrained networks. So we lead the IoT device management by minimizing the communication and the power usage of the devices. We contribute our technology to Open Mobile Alliance, and which is also called Open Mobile Alliance SpecWorks. And we are an elected member of the board of this Open Mobile Alliance, which is the organization in charge of lightweight M2M. We are also participating to the organization, and we are working tightly with several companies who are partnering with us. But let me take a step back. Today, we talk a lot about smart cities in the news, and not for good reasons. We get a lot of attack on cities around the world, and despite the regulation being coming and forcing the people that still are believing that unencrypted, unauthenticated communication can survive, there is still a need for this city to become more secure, and for that, sustainable city will require to follow the cybersecurity rules. The first and foremost rule is to update regularly devices and whatever constraints there are. A sustainable city is a city where the devices, the internet, the IoT infrastructures is updatable. And it's taking another step back. It's important to understand that the ecosystem is completely changing today, and it will change further. We are moving away from the heavy infrastructure of pre-IoT, where only gateways were connected to the internet. Devices today can report to the cloud, but they were not necessarily, could connect to the cloud, but they were not necessarily accessible from the cloud. You could report your data, you could get your data out of those devices, but there were not any possibility to do remote update. There was no way to remote control them. And today, this is changing. Today, we have more and more devices who have direct access to the internet, who have a massive internet of things, where device, thanks to a public infrastructure, and can really report that data, but can also be controllable. That the reason for why this massive IoT is deploying is also for sake of cost. The cost of the device, the cost of the infrastructure make massive IoT now possible. This direct access to the cloud is bidirectional. It allows to control the device and report data in the other direction, but it allows also to have advanced use case, much more advanced use case than in the pre-IoT world. So we are really a need for remotely updated devices, and there are many ways to remotely update a device, many ways to control device, and often it's one per vendor. And there is really a need today to get through the risk that the cost and the risk of proprietary formats and proprietary device management. Interoperability that Miguel just mentioned is coming from a financial decision derived from the sustainability. First, there is a need for interoperability in the data. Today, a lot of device vendors still believe that their business is in offering a proprietary platform to report their device data. Would it be just a light sensor, or just a parking sensor, or just air quality sensor, or just water quality sensor, or just garbage sensors? This is not sustainable. This won't be able to be sustainable in the long run. They are losing traction compared to companies such as Urban Control that are providing a scalable platform that, thanks to a standard brought by the smart city industry, and which is Talk, can provide the same air quality data from the device vendors with different device vendors offering air quality sensors. So this is a really important fact, that if you are still having your proprietary data formats, you will keep yourself in a private garden. And A second and most important fact, but that people often discover secondly, is that there is a must in the interoperability in the device management. How can you install, update, or decommission your smart city device if each of those operations is specific to each vendor? How can you audit each of those proprietary device management operations to ensure safety on your devices? Are they all using the same public key infrastructure? What is the duration of each device certificate? Is it 2 years, 5 years? How can you ensure the overall integrity of your smart city? For that, there is a need for a standard for device management, and that standard exists, and that standard is deployed by people like Urban Control and others, and it's lightweight M2M. Device management standards cares about touchless secure network installation. It is not the business of your field operator to have a PhD in telecommunication, nor to live or to use Excel sheets in the field with key and or passwords. Device management standards automates operations and get your people away from conducting firmware update device per device or through a remote way or through a visit. You have here with a device management a solution that can help you scrutinize tons of log automatically and not having someone looking at them. The device management standards get your team away of being up at 2 a.m. to process an alarm that is regularly happening and that for which you know how to fix it and that you can run a script to fix it. Device management standards help you control who can access which part of your fleet in your team. Each being given a particular access control, say a sport equipment department may not have access to the traffic light devices, but just the devices or sensors that are related to a stadium. Last, the device management standards also define standard data format, and it does provide not only the interoperability at the device management level, but at the data level. And thanks to lightweight M2M and IPSO Alliance, there is a data format which is common for multiple devices that are common in the field, like garbage sensors, like air quality sensors, and all those devices have been made thanks to UC5. They have been made compliant to the talk data format, bringing to life solutions such as Urban Control. So the smart city, taking a step back, is all about interoperability. You have a myriad of interoperating devices that you need to sustain for decades. And smart city is the conjunction of those myriad of sensors that you use for providing multiple cases, multiple interaction scenarios. So the interoperability is extremely important when one of your objects depends upon another's data to fulfill its full potential, which is essential for smart cities. Those devices are installed for decades, and it's the second thing that you need to keep from this discussion. You must update them regularly. And just like your smartphone, to fix possible attacks or add features as you grow the device ecosystem. But you are always in front of your smartphone. You can trigger the update. No one can for parking sensors on the road. You have to think about managing the device before you put it on the road. So what happens if you keep your solutions in a proprietary ecosystem? You will get a nice package at the start, but once you get the life of a smart city up and running, you will see fading away the nice bells and whistles. What happens if after 2 years you get non-functionals and you get devices which are non-functionals and you need an update, and that you need to use a proprietary systems for updating them? What if you in the 4 years you will need to you get hacked by someone and you need to re-engage your partner company to update your security system? What if in 6 years you want to install a smart garbage system and you need another proprietary system to get and work on top of your smart city? What if you want to the company which was running that business is out of business and how you will be maintaining those devices for the rest of their life. And there are all sorts of situations today that are really making the situation extremely difficult for those proprietary systems to live upon. A standard VIL would be facing the same situation, but will be getting through that using an open ecosystem of device vendors and compatible city management systems. You don't necessarily now have a fixed bottleneck of one proprietary device management or proprietary data. You can use and compare vendors, find the one that are offering the best rate or the best features that you need, and you can remotely update them, whatever the device are, whatever the heterogeneity of your fleet, and you can add seamlessly another CMS, another city management system, or you can also put another SCADA, or you can plan your city to be really attractive to other businesses, and that's really what's getting with interoperability. So lightweight M2M, I mentioned before, is a proven IoT device management. It has been around since many years. It has been deployed initially on billions of M2M devices. It is a must for telecom service providers. Telecom service providers use lightweight M2M to monitor the quality of their service, quality of their coverage, quality of the modems which are used and that are whitelisted or blacklisted, and logically, their efficiency made it the best solution for smart city. It has been embedded in hundreds of millions of modems, and it's now embedding into thousands of devices in smart cities. And UC5 married lightweight M2M with Talk to make it a must for a smart city. So what does IoTerop in this ecosystem? We help city management software such as the one run by Urban Control to build and to use our device management platform, not only to be compliant with the standard, but also to provide one which is extremely efficient in terms of data by using binary object and the last version of it, and getting also the lowest communication plan and also the lowest energy consumption, because a sustainable city is also a city which is consuming the less energy possible, and that allows also to get less battery swap for the battery operated devices and has less cost in the end. So even further, we are helping beyond the device management platform, which Alaska, we help our customers to build affordable sensors for the most advanced device management use case. We help them using Iowa, our client, which is a universal client that helps our customers to build extremely affordable devices. Our benefits are for city management operators to be able to develop fast their devices thanks to our complete documentation, our numerous code example, as well as our expert support in lightweight M2M. And we also provide a solution which is extremely low cost in operation, because we are helping them to minimize all the operations and automate all those operations, keeping the city secure and sustainable. We have worked with many companies around the world in cities such as Melbourne, Stockholm, Gothenburg, and way beyond. So I'm very happy for you to have listened to this discussion, and that in summary, I'd like to say that the data and the device management interoperability is a must for the sustainability of smart city. IoTerop helps smart city managers to bring the most efficient solution for this interoperability. It's a solution tested worldwide, and you can keep your question at the end. Let me pass hand to Valérie. Valérie, the floor is yours.
Merci beaucoup, Olivier. So thank you very much for staying tuned until that time. So prove that Matt, Miguel, and Olivier Insight were very relevant here today. So let me introduce myself. So my name is Valérie Gros. I'm working on the SFR business team as a market lead for IoT and 5G. So I've requested the control, but I'm sure I've got it so far. So maybe Mackenzie, okay, yeah, that's good now. So I'm going to start giving you a bit of flavor of what we are doing and from a mobile operator perspective. And the first slide will be around Altice. So SFR is part of the Altice Group. Altice Group is a multinational telecommunication, cable, fiber, content, and mass media company. So we're currently present in 4 regions. Western Europe first, with France, Portugal, and the UK as well. We have cable TV activities in the US, Israel, and also overseas in the Dominican Republic, where I was last week. So in essence, we are providing very high-speed based services like TV, internet, fast broadband, and in certain countries, in some countries, mobile telephony to residential and corporate customers, like in France, for example, or in Portugal. So roughly in 2021, we are over 70 million subscribers worldwide. Also to be noted is that we have an innovation hub in Portugal that benefits to all the other group companies as part of our very sustained technological strategy. It means that we are investing and investigating in the future to make sure that we can provide the best services. So let's deep dive into SFR in France. So we are the second largest telecom provider in France. We have roughly 25 million FTTH or FTT-based sockets listed. And also we have a very strong commercial presence and mainly through 600 headcounts that are also supported by a strong retail network. We were, from a mobility perspective, we're the first to launch 5G in November 2020. And until now, we've made the choice to quickly deploy the 3.5 gigahertz band in more than 4,000 cities, which is the best compromise between bandwidth and coverage. And I think in the future, in the next month or in the next 2 or 3 years, 5G and IoT, including for smart cities, will be very important as well. Noting as well that we are covering with 4G already 99.7% of the population coverage in France. Also going along with 2G, 3G, and LPWA networks, but we are going to come back to that part afterwards. Our goal, of course, is to make sure that we can assist the customers in getting their digital transformation right first time with our range of services, extensive range and services, which is on top of mobility and fixed capabilities. We are also providing unified comm, data centers, security and ICT, and also customer relationship. So now moving to IoT a little bit more. So this is a few bullet points where what we think is important when talking about IoT and NB-IoT for our customers, that could be smart cities or other big industrial customers. So the first thing is the seamless service continuity in France abroad. So in France, it's around multi-operator SIM cards. So when there is a signal loss, then the SIM cards will automatically move to another large network in France, ensuring that your device will still be connected to and provide data to your cloud or to your platform. And abroad, it means that we have more than 600 roaming agreements, mainly also through the Vodafone Alliance. So wherever your device will be, then it will be reachable, and you will be able to send data. Centralization, simplification, consolidation, I think the 3 words are very important, because it means that you're going to have one SIM card to access all the SFR networks. Centralization through our single point of entry, through our pre-sales, our sales team. We also have a dedicated marketing team around IoT, and consolidation, because we are our customer journey is digitalized within SFR. And also we have one IoT platform that could deliver to you everything around your connectivity. That means from a cost perspective, from a status perspective, and from SIM cards lifecycle perspective as well. So the bundles, we go from 500 kilobyte to 1 terabyte that can be pulled. We can also provide you with tailor-made or bespoke tariffs, and everything is on demand. So again, we're very flexible here. Last but not least, wherever you are, whatever your object needs, then we are providing networks from high speed to low speed. We have security levels. We're going to come to this, and it has been explained also by Olivier, and we have also several SIM formats. So now, when talking about technologies, so what could be the right IoT connectivity for your smart city project? So we have seen already with Miguel that coverage, bandwidth, power consumption, the cost, and the security, and of course, let's not forget interoperability are very, very important. So what I'm going to go through now is all around the key technology. I'm not going to spend too much time because you have seen all this and you know all of this. But let's start with the 2G and 3G. So 2G and 3G is really for basic access, basic measure. So it's widely spread, not for too long, to be honest, because there's a lot of discussion ongoing in Europe, and especially in France as well, to stop those two technology. So it's not widely used for IoT, but it has the merit to be there and can be used if as a fallback, for example, as well. 4G, high bandwidth, can support, can be a basic intelligence enabler, I would say. So it's rather from monitoring perspective, like traffic, like videos, like grids, like it provides performance and bandwidth. 5G is very interesting. I do really think that 5G will be very interesting in the future for smart cities. So today we've deployed a 5G NSA non-standalone network, which is kind of an evolution of the 4G network. But tomorrow, so it means in by the end of 2022, very beginning of 2023, we're going to provide a 5G standalone network, which is for me a revolution. And the three key components of 5G SA for IoT is around massive machine type of communication. So it will support billion, let's say million maybe, or let's say billion, let's be optimistic, billion of devices that could be connected at the same times in the same area, which will be key for smart cities, for example. URLLC, which is very difficult for me as a French to pronounce. So it's everything around low latency. So it's going to be more about critical IoT. So anything about the security of the goods, security of the person within a city, that could be very very important as well. The last one is about enhanced mobile broadband, which is in the context of smart cities could help to transfer data between equipments to the edge or to the cloud server in a more easy way. So in essence, 5G SA will provide enough bandwidth to process and manage simultaneously billions of data from multiple systems at the same time. And this is where, again, interoperability is very, very important. Moving now to NB-IoT and LTE-M. So those two technology, and again, we've seen with Matt Miguel that are two technology for the future. They're very similar. They're very perennial. They're part of the 3GPP standards, and also they are compatible with 5G, which is very important. The key difference between both, I would say, is around mobility. So NB-IoT is mobility limited, latency. LTE-M has a bit more latency than NB-IoT. And the cost of devices is in favor of NB-IoT for this one, which is very low cost devices for NB-IoT. So NB-IoT is very ideal for simple static sensor and very limited nomadic application. So it's perfect for smart cities, it's perfect for building, it's also good for smart lighting and also smart parking. Versus LTE-M, So you will be able to track your fleet, to track your buses, to track the vehicles around the city, and also to provide some very simple security activities, not activities, but functionalities. Two things here that for me is not widely known, but first of all, SFR will complete the NB-IoT network rollout in France in 2022. And also, at the same time, we're going to launch an LTE-M network, and of course, the associated services, as you can imagine, in 2022. So it means that by the end of 2022, we are going to cover with NB-IoT and LTE-M 99% of the population in France, which is going to be then a good opportunity to provide more services to our smart cities. So why we've chosen in 2019 to deploy NB-IoT? Well, because it's global, it's sustainable, and it's scalable. So it's definitely dedicated to massive IoT. It's definitely the right choice if you want to have an indoor or deep indoor penetration. So really going in the basement of your buildings. Of course, the management of the device with a low consumption, so the battery life can go up to 10 years. Of course, it depends on the radio signal strength, depends on the use case as well. So will be the best fit for what you want to do, because it means low maintenance, means that you do not need to go to change the battery of your device every 2 years. And of course, it's bidirectional. So it means that you can get the data and also action, simple action to your device, and ask your device to complete some switch off, switch on, for example, or make sure you can detect the right thing and close the door, for example. And from a quality of service and quality of experience perspective, it's license spectrum. It's very important. It means again that it's perennial. It's going to be long term. It's going to be there in probably the next 5 to 10 years. And also, and we discuss about this from a security perspective, we have security in the SIM cards, we have security in the APN that we are providing alongside with the services. The platform can be accessed only with limited, with huge security, and there is ciphering, inherited ciphering, and also integrated protection that are in the SIM cards. Now moving to what we think about what city needs from IoT, again, from an operator perspective. So we've learned with Matt that, and with Miguel, that by 2050, 2/3 of the population will probably live in the city. So it means that there is a significant shift that will be made going from the countryside to the cities. And of course, the cities will need more scalability. It means more people, probably younger, more digital, on demand. It will be now. So it's the reason why we need to scale up very quickly and add more devices all along to the city. And of course, the massive mesh type of communication and the massive IoT and IoT provided by NB-IoT will help here. Security. Olivier has touched the subject. Security, I mean, the threats are various. There are numerous to smart cities. We can talk about privacy, theft, data, identity, also device hijacking, the man in the middle, permanent DNO of services. So there's a lot of things that can happen to your devices, a lot of things that can happen to the solution. And we are currently working with our IST partners, so security specialists, in order to make sure that the endpoints and the end-to-end IoT solution is also secured, because it will include more data as well. So we need to protect the data of our customers. The return on invest things. So we know that we'll need to how can I say, I mean, rely on experts, like for example, we're back on Control, in order to approach our customers, and we need to make sure that alongside with those experts, I mean, our customers will make the good choice, because changing a complete streetlight organization or structure to a connected one will require time, will require effort from the city. So we need to make sure that from day one, they're going to do the good choice, and the reason why we're making some partnerships. So, and NB-IoT in that sense as well will allow the cities to make sure that the devices and the hardware is not the big bang, and that we can have more services at Twin. So in that sense, NB-IoT fits perfectly with the return inverse maximizing aspect thing. It's the same in the same spirit. So the life cycle costs are also important. So again, I was saying a little bit earlier that we need to avoid, people from the city or maintenance to go on the lampadaire to change the battery, to change the things. We need to have very robust, reliable devices, long-lasting, that will be set and not move during a few years, and make sure that the problems and issues will be elsewhere, but not in the IoT solution. Reliability, so all the systems are interconnected. Again, interoperability here. And also, if you cannot, for example, if you want to charge your electrical vehicles and it's not working, it's not going to be nice from a brand perspective. It's not going to be nice from a city perspective that the end user cannot do it. So again, we need to have very reliable network here. The way we see the future of the smart cities, there is 5 pillars here. It's of course there is a lot more probably, but it's the key one in our view. So the first one is smart metering. So what's important to a city is the water, or to the people, the citizen living in a city, is water, electricity, and waste. So in order to be able to manage those one, so this is very basic needs that people will need more and more and more, and probably it is easiest to deploy with low power wide area networks, for example. So this is the first step. Smart lighting in France, with examples where the money spent from a city on smart lighting, on lighting, is around more than 40% of the total budget of that city. So it's really an obvious target where we could easily do something and improve the savings for those cities. So it's an easy one to go to. Don't say it's easy to deploy, but I mean, again, with the experts, with the right partners, it's something that can be easily done. Electrical vehicle charging, we see more and more electrical vehicle around. So again, we will need places where it's going to be important that they can charge the vehicle, they can pay with their credit cards, for example. So reliable, bidirectional to process the transaction, to provide the telemetry data, and to ensure that all the activities are done. So we see that we're going to move to, for example, just in the UK, to 21 million electrical vehicle in 2030. So you can imagine the size of the market here. Solar system and environments, a little bit the same. So environment, the pollution is becoming a problem now in the last decades due to vehicles, due to outdated infrastructure in the air, in the soil, in the water. The decarbonization of the cities and buildings is now becoming a priority for everyone. So improving the environment quality, thanks to IoT, and improving the operational efficiency is key. And the solar system, so it's going to be a good way to transition to a clean energy. And again, IoT will help to supervise the photovoltaic power generation plants here. Let me just end with 2 slides. So the key focus for us in 2022 when talking about IoT, so I mentioned the NB-IoT network, I mentioned the LTE-M proposition. So it's going to be from now up to the end of 2022. We are also going to work with partners in order to enrich some device catalogs, and we're going to boost our partnership program because, again, the expertise is elsewhere, the expertise is around us, and we really want to work closely with the people that will make the right turn on the market. Last slide is our vision for smart cities and sustainability. in 2022. So, of course, the key objective of our city is to increase the quality of life, to reduce the carbon footprint, and to improve the operational efficiency. So it means that they want to improve the life of their citizen, and they want to make savings on the money they are spending on managing, so automation, integration, and managing their cities. So all they want to do this, they want to make sure that the right technology is available wherever they need it. They want to get the right tools in order to get the report, get the data, make the right action, make the right decision. So get the information for device management platform, for example, from data platform, and ensure they can have these. They have one platform for all their devices, for all the networks, for everything. So the key areas for us and will be around sustainability. So this is kind of the title of the webinar today. So it's a very easy one. So it's around energy, it's around water, it's around efficiency. So how we can reduce the street light, how we can monitor the traffic in order to divert the traffic where it's going to reduce the carbon footprint, the people, it's going to be connected cities, it's going to be smart homes as well, and security. So how we can detect, protect, and make sure we can potentially change the behaviors of the citizens as well. So just let's not forget talking about smart cities and where we are when we are implementing a smart city structure is it reduces the key life indicators. So the crime, the accidents, the carbon emission. It's very important we can communicate on those one, because it's an effort for the city for the good wealth of the citizens. So we need to make sure they're fully informed in order not to be too dramatic when they see a video, for example, or camera. And we need to help the cities to make better decisions. And we're going to help them to make better decisions thanks for all the data that will be connected. Here we go. I hope that I was not too boring, but it was important for us, SFR, to share our view on the smart cities and the way we would like to evolve in the next future on that subject. So thank you very much for your attention.
Thank you, Valérie. Thank you for your explanation and for presenting the potential of 5G and urban IoT for SFR in France and for the whole Altice group also potential. I think that's interesting to see that, and we have plenty of questions. So I'll start maybe with the first one, although I'm not sure that John Kaipa is still here, but John asked about LoRa and Sigfox as more deployment around the world than Narrowband IoT LTE-M. LoRa and Narrowband IoT may be complementary. A multi-technology strategy is more appropriate for cities. Maybe Matt, could you elaborate on this sentence and give your thoughts on that to start with?
Yeah, absolutely. Happy to. This is always a case of different technologies will be appropriate for different applications. Now, I'm not quite clear from the question whether he's talking about using multiple technologies in a device in order to have potentially the best of both worlds. That's probably not a great idea when you're working in constrained environments, because if you start building two radios and two sets of technologies into a device, the battery life will probably suffer quite dramatically, and the price will go up. So that would seem to me to be not the greatest of ideas, given that, you know, if you've decided that what you want is a low power technology, then using multiple bearers is probably not the greatest idea. But if what we're talking about is for any given city, say, wanting to have available multiple technologies, yes, absolutely, because there'll be some use cases that demand certain functionality. Voice would be one example, right? You can't do voice over narrowband IoT, but some use cases might require voice. Whereas other technologies, if all you're doing is sending a small amount of data and you don't need it to be particularly secure or particularly low latency, then LoRa would work well. So it's not going to be a single technology that dominates. There are going to be multiple technologies.
Thanks, Matt. Miguel, can you elaborate on it as well? Do you have your thoughts on this?
I have. I mean, my view is all about simplicity. I understand what Matt said and was referring to when you need voice or you need, let's say, larger bandwidth, like for video, for example, streaming. I understand that. But if you're, for example, speaking about these device constraints, these battery power sensors and even a lighting controller, I think it's all about to make it less complex. It's all about interoperability and all the way through, right? And we want to make it simple for the cities. We want it to be as much as plug and play possible, as much as less infrastructure needed, and I think they will coexist for a while. I mean, it's still rather new technologies. They have a couple of years, right? I mean, the low power cellular solutions, but we will see more and more, and we will see how that will become the preference of the cities as really, I mean, in terms of impacting the expertise needed, the time for deployment, the simplicity of operation. I think we'll see more and more, let's say, these new technologies being deployed. But yes, I mean, it won't be the case that one will fit all requirements, right? So they will coexist for sure. But I think the low power cellular, for the majority of massive IoT deployments, will be predominant in the next few years. There goes.
Thanks, Miguel. And I'd like to concur with what Matt said about having dual stack, dual technology running on a single device goes out of the affordability and constraint of those devices. And I also concur with what you said, Miguel. It's two technology, but one requires to run an infrastructure. So you have to have the infrastructure on top of it. And for running a LoRa network is different than using a network infrastructure proposed by companies like SFR. It's very much different. The OPEX, the operating expenditures, is very much different. And I'd like to say that also this is the subject of this webinar is sustainability. We have worked long enough, and to answer a bit of the question of Pomengo, I'll ask later, that is later in this thread. We have tried lightweight M2M over LoRa. We have done lightweight M2M over LoRa, and today that technology cannot provide a reliable return path. So we cannot remotely control devices in a secure way, in a reliable way, and that's preventing this ecosystem to be sustainable in the long run. And that's our. It may be the case that LoRa make it evolve. I'm not seeing that in the latest version LoRa FHSS for satellite. Maybe it will be a new generation, but today the device management provided by LoRa is proprietary to LoRa and is not necessarily able to do it. So there was also a question from Comengo about global roaming of narrowband IoT. François Dupont answered. And he answered back also the question on the question. Maybe François, you want to add something to that item? So maybe present yourself, François Dupont, in charge of SFR radio access at SFR.
Yes, well, as I mentioned in my answer, the roaming agreement are gradually put in place by SFR for roaming in and roaming out, right? So this is work in progress for narrowband IoT, and it will soon start also for LTM, because as Valerie mentioned, LTM will be launched in the later this year. Having said that, what we can say that for roaming, the main obstacles are not really technical, they are more financial. I mean, there needs to be an agreement between operators, because we are speaking about very low data usage. And I believe this was the main reason why narrowband IoT roaming took such a long time to take off. But I think those hurdles are now behind us, and it's gradually put in place, not only by SFR, by the way, but by other major players like Vodafone, etc.
Thanks, François. There is another question which is directed to you or to Valérie, which is how do SFR lead market to transfer legacy multimedia 2G, 3G devices already deployed to LPWA or Cat1? Can they be switched by 2025? Is it something that you want to answer, or Valérie?
Well, it's a tricky question. So it depends what the need on those on devices and what they're currently doing, and what the customer would like to do in a few years when it's going to be switched off. So it depends. I think it's going to be a case by case, but of course, I mean the thing is we still going to try to be very flexible and agile here in order to find the best solution for our customers. It depends if there is voice or SMSs included or not. So maybe the best solution will be to directly move to 4G or to 5G. Depends. What's the need here?
I think what I can add additional comments on this. I think for 2G, LTM might be the natural replacement for this technology, also because it supports SMS. But again, the extension of those technologies is really a major trend worldwide, right? I think recently Orange, during the Barcelona Mobile World Congress, announced that they are going to close 2G, I think it was in 2025, and 3G in 2028. So it's it's a trend that all players should take into account for sure.
Matt, Miguel, do you want to add something on the narrowband IoT roaming question?
Yeah, just quickly. It's been a little slow to materialize, but these agreements are being struck between the various operators. But what we're tending to see is NB-IoT mostly up until now being used for national deployments rather than for multi-country deployments, and actually it's LTEM that tends to be the favored one for multi-country deployment. So it will come. It's really just a matter of time and getting the agreements struck rather than any technological limitation or anything like that.
Thanks.
Yeah, I would tend to concur, especially because LTM is not a new radio access technology in 3GPP terms, right? KTM1 and or possibly KTM2 are just additional categories added to LTE, whereas and narrowband IoT is a new radio access technology itself, right? So it takes it requires dedicated cells, etc., dedicated infrastructure. So this is also the reason why LTM roaming is much easier to set up than narrowband IoT.
Thanks. Miguel, anything you want to add on that question?
No, I was mentioning that yeah, I mean, as was answered, it's more a commercial question and arrangements than let's say the technical part.
Thanks.
Will come. Yeah.
And so to answer also Kwamengo, and I think it's quite late in Singapore, I'd like to answer the questions about does Lightweight M2M support LoRa and Sigfox, or are there use cases of LoRa or Sigfox using Lightweight M2M? So I've partially answered that questions before. I'd like to comment on Sigfox. So Sigfox having no return path, you cannot remotely control a device using Sigfox, or you cannot send back any information. So it's not possible to do any device management per se. That's a big limitation. We have two more questions coming up. One is from Said Garut about, do you use eSIM or only SIM cards? I think that Miguel, you are targeted here.
Yeah, no, we use eSIMs. Yep, eSIM card.
And we have another question pretty long from Katrina about 1 billion devices will last only for 5-10 years. This will lead to a lot of waste at the end of their lifespans plus low ROI. This doesn't seem to be sustainable. Is there any push for the devices to be recyclable or for them being backward compliant? Is there a push to make use existing camera where possible instead of deploying specific sensors? For example, to detect passing traffic, parked cars via AI rather than deploy separate set of IoT devices. So I can take a stack first and maybe if someone, but so yeah, sustainability is something that we know about. We are running, for instance, in the water metering industry. We are deploying devices that are that last 30 years for concessions that are lasting 30 years, so 30. So this is extremely important to have a way to manage the device to have it sustainable. And to make it sustainable, you also need to have that remote device management, because if not, you won't be able to make it live and keep it up. It will be just exactly a lot of waste if you are just devices that are flashed one time, but you will never be able to use ever except at swapping them. And this is happening in some portion of the market, like for instance in the smart bike or smart scooter industry, where people tend to just throw away the devices rather than replacing them. This is not the way to go, and for that you need to have an extremely important part of it should be the sustainability. To the question of using other sensors that are more generic, I would maybe raise the question of the privacy. Having camera everywhere also reach some questions about the privacy, and that's also a topic that is important. Is someone else wanting to take a tag at that stab at that question?
I'm happy to jump in on it if you want. So I think the issue isn't necessarily one of replacing or throwing away the device. It may well just be after 5 years you've got to go and replace the battery, right? So it's often as simple as that. It's not always just a replacement, and we have to bear in mind, we did a study about 12 months ago. If you go on the Transforma Insights website and search on sustainability, you can download a copy of it, looking at the impact of IoT technology on fuel savings, water savings, power savings, or everything related to being environmentally sustainable, and the positive impact that IoT has overall, including taking account of manufacturing the actual devices and disposal of them and all of that sort of thing. So considering the whole device life cycle is incredibly positive. It has a very positive environmental impact. So there may well be some wastage, but overall the benefits that accrue as a result of IoT are overwhelming compared to the environmental cost.
So if there is, thanks Matt for that answer. I'm not seeing any more questions, so I'd like to thank you a lot for attending this webinar. I'd like to thank also all our partners, so Valérie, Miguel, Matt, for making this event real. And I'd like to encourage you to see what Urban Control, Transforma Insights, and SFR are proposing. You can also go and watch our series of webinars on different topics, on other topics on smart city, topics on narrowband IoT, topics on water metering, on massive IoT. Don't hesitate to give a look. And I'd like to thank you all for attending, and I wish you an excellent continuation. Thanks. Have a good day or evening.
Thank you very much.
Bye-bye.
Thanks to everyone. Bye.
Thank you. Bye-bye.
Everybody, bye-bye.